Let us solve another problem on strain. Now we will be solving the problem on rotation of the axis. How we had solved the problem based on rotation of axis and stress, same way we are going to solve. There is going to be no difference at all. Alright, first let us try to find the direction cosines. Direction cosines, as it was mentioned, cos theta, sin theta, minus sin theta. In the case of stress, we will be utilizing the same thing. So the problems with strain is going to be very much similar to that of your stress. Alright, there is not going to be any much difference at all, just that instead of sigma x, sigma y, sigma z, there is going to be epsilon x, epsilon y, epsilon z. That is what is going to be the only difference over here in strain. So there is no need to study two times when it comes to strain, because we have already read about it in stress. So just the application of it is going to be done over here. So I'll write down the values of the direction cosines directly. This is x, y, z. X dash, y dash, z dash. They have given that it rotates about 45 degrees. So it's going to be 1 by root 2, 1 by root 2, 0, minus 1 by root 2, 1 by root 2, 0, 0, 0, 1. Yes, we have already solved. Given that we have already solved, I am writing it directly. So this is nothing but L1, this is M1, and then this is N1, and then this is L2, M2, N2, L3, M3, N3. We have an equation with respect to strain in the form of a matrix, that is epsilon dash, the new set of strain components, is equal to matrix A times matrix epsilon into transpose of matrix A. Alright, this transpose of matrix A, what we have written is nothing but, first let us see what is this A. This A is nothing but the direction cosines that we have written over here. So I'll just write it in terms of a matrix. So it is 1 by root 2, 1 by root 2, 0, minus 1 by root 2, 1 by root 2, 0, 0, 0, 1. This is matrix A, that is our direction cosine, and transpose of it is nothing but the columns will become the rows are going to become the columns. So it is going to be 1 by root 2 minus 1 by root 2, 0, 1 by root 2, 1 by root 2, 0, 0, 0, 1. Alright, so let us start substituting. Let us take matrix A into epsilon first. I am taking these two terms. Okay, so matrix A is 1 by root 2, 1 by root 2, 0, minus 1 by root 2, 1 by root 2, 0, 0, 0, 1. And the strain matrix, that is nothing but values that has been given in the question. These form the strain matrix. Okay, I'll fill them up over here. So it is 0.1, 0.08, 0.08, 0.08, 0.2, 0.08, 0.08, 0.08, 0.3. I will be doing matrix multiplication. So this is matrix multiplication that is going to be done. This is a simple way in which you can solve. So after the matrix multiplication, we will get 0.127 minus 0.014, 0.08, 0.198, 0.085, 0.08, then 0.113, 0.3. Alright, so this is the product of matrix A and matrix epsilon. Next, we need to multiply it with transpose of matrix A, that is this particular matrix. So matrix A into epsilon into transpose of it. Matrix A into epsilon is 0.127 minus 0.014, 0.08, 0.198, 0.085, 0.08, 0.113, 0.3. This times, write this matrix down. So it is 1 by root 2 minus 1 by root 2, 0, 1 by root 2, 1 by root 2, 0, 0, 0, 1. Alright, so again we will be doing matrix multiplication for these two. Please do the matrix multiplication in your scientific calculators, which is much easier and quicker. This is a 3 cross 3 matrix. This is also 3 cross 3 matrix. These two must be the same for the matrix multiplication, and the resulting matrix will be in this order. Okay, so I can write the new strain components, or the product of A into epsilon into A transpose. The matrix multiplication values come out to be 0.23, 0.05, 0.113, 0.05, 0.07, 0, 0.113, 0, and 0.3. One way to cross confirm if your values are correct or not, other than the principal diagonal elements, just see that these values will be the same. So this confirms that whatever matrix multiplication that has been done is correct. And then I can write, therefore the new strain components are epsilon x is 0.23, that is this, and epsilon y is 0.07, epsilon z is 0.3. Then half of gamma xy is 0.05. This is going to be half of gamma xy. Alright, or I can write gamma xy is 2 times 0.05, that is nothing but 0.1. Then gamma yz is 0, this term. Then gamma zx is, let us write as half of gamma zx as 0.113, or gamma zx is 2 times 0.113, that is 0.226.